generally just do them in the order that they come in, because that's what I see here. So I've got question one here. Looks like you've kind of already done it. Do you need me to check it? Do you have questions? What?
I think it's right, but could you just like check it?
It is correct. Yes, you have 100% correct there. So no issues there. For part B, there's no work. Do you want me to do any work? Talk about how to do it?
No, I think I have that part down. Uh,
Right,
just like plugging it in and stuff.
right. So part C, I guess we'll start with then.
Yes, please.
All right. So here we go. I'm going to snip in this here. You're already seeing my screen. Just double check that. All right. So it says what happens to the tangents of the curve at the point A, comma 1 over A for all values of A. So the tangent refers to the tangent line, the slope, things like you've been studying here. We know that the slope at A is always minus 1 over A squared. And so I'm not exactly sure what they want here, but we could start with writing the tangent line, something like this. Sometimes it falls out of here. Y1 is 1 over A. Your slope is minus 1 over A squared, X minus A, like that. Is that okay so far?
Yeah.
All right, so if we distribute this in over here on the right, it's minus X over A squared plus A over A squared, which does reduce to just 1 over A. And we know that if we add 1 over A to both sides, that leaves us with Y equals minus X over A squared plus 2 over A. I don't know. I don't see anything going on here. But I don't know if you have a solution to this. Maybe it provides some sort of input to what this is. I have no idea what
No,
the
I don't
answer.
think I do.
Yeah. So this is one of those problems where you would, this is not a free response type question on the AP, by the way. This is maybe in the multiple choice, maybe,
Hmm.
but A and parts A and B would definitely be that you already did. So uh maybe it's asking because the slope, maybe it's being more general. So so for all values of A, the slope is less than 0 for all A, because when you square A, it's always positive. That's negative on the top makes it's negative. So it might mean that the tangent line is always decreasing, or that it's going down and to the right. That may also be more of the general thing that it's trying to address there. Not really
Oh,
sure.
okay.
A little more open-ended than it should be.
Hmm.
All right, we'll start with we'll head to number two. Any questions or concerns before we move on there?
No, I think I got that one.
All right, so the height above the ground after t seconds, h of t. Any chance you're taking a physics class or have taken a physics class?
I'm not.
You're not. Okay, so this is the equation. It says the height as a function of time is 100 minus 4.9 t squared. So that means if I give you a time, we can figure out the height. Graphically, it looks like this. Comes down, hits the ground as a parabola, U-shaped. Now we're wondering how fast. Fast refers to speed, velocity. That is the derivative here. Now, have you guys learned the derivative rules yet in this class?
We learned like limit h to 0, but that's about it.
Ah, all right. Yeah. So we have to do this the awful way, which you will dislike. So just to make this easier, I'm gonna switch to X because that's probably what you're seeing in the classroom. Let's
Hmm.
call this f of X. You then also need what's called f of X plus H, which is where you put X plus H in for X, like
Hmm.
that. And then what's your comfort level, foiling, multiplying? How comfortable are you with all of that here?
I'm good with that.
Okay. So the faster you get at this stuff, the better you will be able to get a good grade on the AP. So the stronger your algebra is, the more you're able to deal with problems like this. And just getting fast really does help here. So this is f of x plus h. This last line here, this is f of x. So the derivative is the limit as h goes to 0, f of x plus h minus f of x all over h. I assume you've seen that a bunch. It's what you used in the email you sent. I didn't know you could make your profile image on your email a GIF.
Oh yeah.
Yeah, I didn't know that. I didn't actually never even thought to think of doing that. That's interesting. All right. So we have all these things. So it's the limit. And if you're doing it officially, you really are supposed to write this limit every time. So it's all of this. I have the benefit of copy and paste here. All of this minus 100 minus 4.9 x squared all over 8, like that.
Mhm.
And then most students are, you get tired of writing here. So I kind of get it here. You can show the distributing the negative inside here. You make sure you notate that it's gone. Now your check is that everything that is left over after you get rid of these terms, you'll see that you can get 100 goes away with the minus 100, minus 4.9 x squared goes away with 4.9 x squared. Everything that's left over should have an h in it.
Mhm.
That's your built-in check here. The h has to cancel, and it does. All right. So you divide each of these by h. It's not a choice. They both have to be divided by h. So you get minus 9.8 x minus 4.9 h. And the reason we can now finally find the limit, put 0 in for h, is that we're no longer dividing by 0. Dividing by 0, it's a terrible thing to do in math,
Mhm.
computer programming. So when you put h in for 0, you get minus 9.8 x minus 4.9 times 0, which is just minus 9.8 x, and that is your derivative. Take a breath. All right. The reason I asked if you learn the derivative rules is because in about a week or two, or after this first test, you'll learn how to do this in one line. You'll wonder why you had to do all of this to begin with.
Oh.
But the velocity, or the function of time, is minus 9.8 t. So if you go back to the original question, which says, what is the velocity, or how fast is it falling after 2 seconds? It is minus 9.8 times 2, which is minus 19.6 meters per second. Now we got to be careful here. It says, how fast is it falling? It's like when you drive your car doesn't know whether you're going forwards or backwards in terms of the speedometer. It just registers the speed. Um, you got to be careful here. The correct answer may be that it's going 19.6 meters per second because it's asking about the speed, not the velocity. And if you're not sure what I mean by that, maybe throw that question back at your teacher. Say, hey, working through question 2 and, trying to decide whether the answer should be positive or negative, and let them see what they say.
Oh, okay.
I wish I had better information, but I don't teach your class, so can't help you on that one. All right. Okay, so these are all just kind of looking ahead here. So we're gonna go for till about 9:25. Um, if you want me to skip through any of these, let me know. I mean, 6, you kind of 5, 6, 7, and 8 are all difference quotient limit, uh, definition derivative difference quotient. You've done one like 6, 7's a little different, but 5 and 8 are quadratics. They're similar to what we just did. Or I can just go in order here if you would like.
I think just the front is fine because I'm pretty sure I know what to do on the back.
Great. The one you're missing on the back is a square root, and I don't know if they will cover that, but that is one to consider or maybe ask in class.
Mhm.
All right, what is the rate of change? So you're seeing a lot of the same, it's a lot of language. Your rate of change means derivative, tangent, slope, rate of change, derivative. These all are the same thing. Derivative, derivative, derivative. In this course, for most of the year, you're learning about derivatives. So the area as a function of the radius of a circle is pi r squared. Looks like you wrote that at the top there. I'm going to use x just because that's kind of the notation you're used to seeing. So again, you need f of x plus h. So it's pi x plus h squared. If I said I'd ask you to get involved, will you expand this for me and tell me what this becomes when you multiply everything by pi and expand it there, please?
Okay, one sec. Would it be 2 pi x squared plus 2 pi hx plus 2, wait, plus pi h squared?
So I'm hearing some things I don't like. When you FOIL this, and if you haven't done this in a while, that's why it's good to maybe write it out. You
Hmm.
get x squared plus 2xh plus h squared times pi. So the only thing that's got the 2 in front of it is the middle term.
I think I just tripped up my words, but yeah,
Okay, yeah.
that's what I meant to say. Sorry about that.
So the good news is you're not graded on what you say. You're graded on what you write because I
Hmm.
get it. It's not, I do this all the time, so I'm totally comfortable with it. If you wrote this down, that's great. You said something different, that doesn't matter. But if you wrote this down, that's what I care about.
Hmm.
All right. So now the limit as h goes to 0 of f of x plus h is this stuff you just did minus pi x squared all over 8. Uh, do you want to try simplifying this from here? It's very much like the last one. This cancels with something else up here. You can divide by 8 and see what's left over. I'm going to give that a try.
Yes. One second. All right. So after the h's cancel, it would be 2 pi x plus pi h.
Okay. And you still take the limit as h goes to 0. And that's when you're finally ready to put that in. You put that in, so it becomes 2 pi x plus pi times 0 or 2 pi x.
All right. I think I'm good with that one.
Okay. All right. So that is the rate of change. You do kind of want to formalize it by saying, like, if you go back, we said a of r equals pi r squared. I just changed r to x because that's typically the letter you're using, but it becomes 2 pi r is the derivative. That's the rate of change. And if you ever have a question, or if you're ever like, hey, that didn't make sense, just tell me. Just say, that didn't understand any of that, or that was a terrible explanation. Try again. Like like this is for you. It won't offend me. My goal is to help you. Um, if something's unclear, just ask and we'll see if we can figure it out. All right, the equation for free fall at the surface of Mars is S equals 1.86 t squared. So interestingly, Mars doesn't have the same gravity as the Earth, so you could jump really high if you were to survive getting there and survive the extreme temperatures. Um, but I don't know. Are you one of those that's into the travel to Mars thing that we see a lot every once in a
Not
while?
necessarily.
Yeah, I don't get it either. Pretty happy on Earth.
Yeah.
All right, so this is no different than what we just did. It's just got a number in front instead of the pi. Like the last one we did was pi x squared. This is pi t squared. So like, I don't know, at some point I feel like you should be able to say the derivative is, and maybe you're starting to see this. It's two times this number times the variable. I don't know if you're seeing that yet, but if you're not, we got to do that whole difference quotient thing.
Hmm.
Do you have to show your work for all of these?
Yeah.
Okay, darn. Okay, so I'll switch back to x here. So you have to do the f of x plus h. All right, so you want to give this a try here, expanding this for me?
Yes, once again. Um, I got 1.86 x squared plus 3.72 hx plus 1.86 h squared.
Great, excellent. So the faster you learn the expansion of this and you don't have to rewrite it each time, the better. I mean, I would commit
Hmm.
that to memory.
Hmm.
Probably will save you some time down the road. Okay. The next thing here would be uh, writing the difference quotient. So limit as h goes to 0. All of this stuff that you just did, f of x plus h minus 1.86 x squared all over 8. Do you want to simplify that? Give me your final answer here for
All
this,
right.
please.
So after the limit h to 0.
Yeah, do everything. Yeah.
I got 3.72x.
Right, that is the derivative. That is the s prime of x, or if we switch back to t, which we probably should,
Hmm.
is 3.72 t. Now this one actually, and I messed this up here. Let's go back to the previous problem. Whoops. Okay, in the previous problem it says determine the derivative when the radius is 3. I didn't do that. I just found the derivative. We just found the derivative. You need to find a prime of 3, which is 2 times pi times 3, which is 6 pi. And then it's the units here do matter. It's inches per unit time, which we don't know the unit time because it doesn't specify.
Hmm.
So I'm sorry, I did mess that up. Do you please see the correction there? For number 4, we similarly need to find the speed at 1 second. Now this one's better. It says speed. Speed is the absolute value of velocity. This is the velocity function. So we need to find s prime of 1, which is 3.72 times 1, which is 3.72. Units do matter, meters per second.
All right, then okay. That one's good with me.
All right. Might have time here to do one or two more if you want. It's up to you. Be to keep going here on some of these or not.
Um, yeah, could we just do one on the back?
Sure. I recommend not doing 5 and 8 because you kind of already done those unless
Yeah.
you really want to. 6 is very much like number 1 that you already did. So I'd
Hmm.
recommend we do 7.
So I know like how to find the derivative of that, but when it says give a written description of what happens to the tangent at x equals a as a changes, like I'm not really sure what it's like looking for as an explanation.
Yeah, that's kind of like part C.
Hmm.
You want to say whether it's positive or negative or not. So like let me just go through these real quick. So the derivative f prime of x when you do all the work is 2x. So f prime of a is 2a. So the rate of change, so the tangent is you can say that the tangent is positive for a greater than 0 and negative for a less than 0.
Hmm.
and that's the slope of the line. So the tangent line goes up and to the right or down and to the right.
Oh, okay. So then I would just like write it out.
So let's look at the graph of x squared plus 2. So you can kind of see visually what's going on here. X squared plus 2 looks like that. So when a is greater than 0, the tangent lines, you said they go up and to the right,
Hmm.
but when a is less than 0, they go down and to the right. They're
Oh,
looking
okay.
for some words to describe that.
Oh, okay. That makes more sense.
Yeah, so it's really asking you about the graph of the original function and then what do the tangent lines look like. So for number 6, the derivative is minus 2 over x squared. F prime of a is minus 2 over a squared. Now the graph of 2 over x looks like this. And you can see that the tangent line is always negative. It's always got a negative slope. It always has negative slope. Something like that. That's what they're looking for in this.
Okay. Okay. That makes more sense. All right. Then I think I'm good with the ones on the back.
Excellent. All right, so we're gonna go ahead and stop the recording here for today.